Hello all, let's talk about part 2 of section uh, 5.3. In part 2 of this video, we are studying case 2 of the partial fractions. In case 2, as you see in the topic, the partial fraction decomposition of p of x over q of x, but here your q of x has repeated linear factors. What does it mean? This part is important to translate. Q of x has repeated linear factors. If I ask you, what is the LCM between x and x squared? Definitely your answer will be x squared, right? You see, between x and x squared, the LCM is x squared. Or, if I ask you what is the LCM between x plus 1 and x plus 1 squared, of course, the answer is x plus 1 squared, the highest exponent, right? Now, having this in mind, I can write whenever I wanna find the partial fractions for this rational expression of p of x over, if I have in the denominator ax plus b to the power of n, a linear expression or polynomial, a linear factor, but to a power, then how to set the partial fractions? I'll go this way. A1 over, I start with the lowest one, ax plus b plus a2 over ax plus b to the power of 2 plus a3 over ax plus b to the power of 3, plus it continues based on how many factors you have in the denominator up to you receive to the an over ax plus b to the power of n. The only difference between case 1 and case 2 is that you have repeated linear factors in the denominator. To explain well this topic, let's do few examples. The steps are still the same steps. The method is still the same method, but the only difference is how to set at the beginning your partial fractions. Let's deal with this example. For example, I have example number 1, decompose. The problem is x minus 18 over x times x minus 3 to the power of 2. How to decompose this, or how to first set my fractions to the right side? How many fractions I need? Let me show you a technique. You have x times x minus 3 squared. How to know how many fractions you need? Add these exponents. Here you have x to the power of 1. Here your parentheses has to the power of 2. 1 plus 2 gives you 3. It means you need 3 fractions on the right side. Did you see the easy technique to avoid the mistake? How many fractions I need on the right side? Add the exponents of factors and see how many of them you have, and set the right side that much fraction. Now, the first denominator x and the top is still a constant a. The second denominator, I will put x minus 3 and the top b. The third, x minus 3 square, and I put in the top c. That's it. As soon as you set this, the rest of the procedure is the same as case 1. Correct? What you do, you multiply all fractions with your LCD, and this is your LCD. This is your LCD. Correct? You multiply both sides of the equation with your LCD. It means I will do this. X times x minus 3 square times x minus 18 over x times x minus 3 squared equals same thing, x times x minus 3 squared times a over x plus x times x minus 3 squared times b over x minus 3, second fraction, plus x times x minus 3 squared times your third fraction, which is c over x minus 3 squared. Now, next step was simplify, correct? Here, both of them cancels out on the right side. The denominator cancels out. You end up with x minus 18 equals, here x cancels out with x, what left? A times x minus 3 square plus, here x minus 3 cancels out with one of the x minus 3's, what left? B times x minus 3 plus x minus 3 square cancels out with x minus 3, what left? C times x. Still, we have to simplify. But here you see you have a factor of square. You have to simplify that one. Then x minus 18 equals, I'll keep the a, and first I'll simplify x minus 3 square. If you don't remember the special product, you do this. You multiply x minus 3 with x minus 3, and you write your answer here. But if you remember a minus b square, what is the formula? You can do this. X squared minus 6x plus 9. Believe me, when you multiply these two, you will end up with that answer. Plus, here distribute the bx to the parentheses, which gives you bx squared minus 3b plus what? Cx. You see, I'm going step by step. I take the time. I don't want to do a mistake. Then x minus 18 equals, now I'll distribute a to the parentheses. It means I'll end up with ax squared minus 6ax plus 9a plus b squared, bx squared, minus 3b plus cx. The next step was to write the right side in descending order, correct? Then x minus 18 equals ax squared. I'll bring the bx squared close to this. Bx squared, after x squared, I put the x's, right? Minus 6ax x plus cx, right? And at the end, plus 9a minus 3b. It should be 3bx. Why I have 3b? 3bx. Okay, let's order it a little bit because I missed one of the x's. Minus 3bx plus c. Minus 3bx plus c. Plus 9a now. Order it. Factor out the x squared, right? X minus 18 equals, if you factor out x squared, you end up with a plus b and x squared. Here between these three terms, factor out x minus 6a minus 3b plus c and x and plus 9a. Why you are doing this? Because you are comparing your right side of the equation to the left side of the equation and you equate the coefficients with each other. Look, on the right side you have x squared, but you don't have on the left side x squared. Can I rewrite the left side like this? 0x squared? Because any term that doesn't exist in a polynomial or any power that's missing in a polynomial, you can add that power, but you keep the coefficient as a 0. It means you are not actually adding those, correct? Now, let's make our equations. Then my first equation will be a plus b equal 0. The second equation will be negative 6a minus 3b plus c equals what? The coefficient of x. The coefficient of x is 1 on the right side, on the left side. And the third equation, 9a equals what? Negative 18. Here you go, equation number 1, equation number 2, equation number 3. A system of linear equation and 3 variables. This one is easy. You can solve for a first. Divide both sides by 9. Then a equals negative 2. As soon as I have the value of a, b is easy to find. Look at equation number 1. Equation number 1 is a plus b equals 0. And if you plug in the value of a here, it will be negative 2 plus b equals 0. If you add 2 to both sides, then b is equal what? 2. Now, I have the value of a and b. It's easy to find the value of c. I'll copy equation number 2, which is negative 6a minus 3b plus c equals 1. Plug in the value of a and b in this equation. Then negative 6 minus times negative 2 minus 3 times 2 plus c equal 1. Negative 6 times negative 2 gives you 12. Negative 3 times 2 gives you negative 6 plus c equals 1. 12 minus 6 gives you 6. 6 plus c equals 1. Subtract 6 from both sides, then c equals negative 5. As soon as you have a, b, and c, let's go to the last step. What was the last step? Last step is to copy the equation in step 1 and replace the value of A, B, C in your equation. Your equation in step 1 was x minus 18 over x times x minus 3 squared equals A over x plus B over x minus 3 plus C over x minus 3 squared. Just put the value of ABC in the numerators, correct? Then x minus 18 over x times x minus 3 squared equals, how much is A? We found the value of A, negative 2. Negative 2 over x. Plus, how much was the value of B? The value of B was 2, right? 2 over x minus 3. How much is the value of C? Negative 5. Then I'll put here a negative. Negative 5 over x minus 3 squared, and you are done. You decompose the fraction x minus 18 over x times x minus 3 squared. Correct? Let me do one more example for you. One more example. Then I'll stop the lecture and I'll make another video as a part 3. Correct? Example number 2. This one is actually, I think, one of the problems from your homework. 3x plus 16 over x plus 1 times x minus 2 squared. How to set the right side? How many fractions I need? Definitely 3, right? 1 fraction, 2 fraction, and 3 fractions. The first one, denominator x plus 1. The second one, denominator x minus 2. The third one, x minus 2 squared. And the top, A, B, and C. Correct? Now multiply both sides of your equation with LCD, and your LCD is your denominator. This one is your LCD. Then you can write x plus 1 times x minus 2 squared times 3x plus 16 over x plus 1 times x minus 2 squared equals, multiply the same thing to all fractions. Let me do this time this way. You may go this way. X plus 1 times x minus 2 squared times A over x plus 1 plus B over x minus 2. But be careful if you go this way to do not do a mistake. Plus C over x minus 2 squared. Here, denominator cancels out with this. You end up with 3x plus 16 equals, denominator of A cancels out x plus 1 with x plus 1. What left? A times x minus 2 squared. Plus, in the second one, x minus 2 cancels out with one of the x minus 2's. What left? B times x plus 1 times x minus 2. And the third one, x minus 2 squared cancels out with this. What left? X plus 1. Be careful to see it, because this method, I don't like it. Why? I distribute to all the fractions that you can see, but some professors, they're going this way, or some of you like this way, but be careful to do not mess, correct? C times what left? X plus 1. Now simplify. 3x plus 16 equals 8 times, again, x minus 2 squared means x squared minus 4x plus 4. Here, keep the b. First, multiply these two factors. X times x gives you x squared. X times negative 2 gives you negative 2x. 1 times x gives you x, and 1 times negative 2 gives you negative 2. Plus, distribute here the c. Cx plus c. 3x plus 16 equals, here distribute the a. It gives you ax squared minus 4ax plus 4a. Here, before distributing, you can simplify these two terms, right? Negative 2x and x gives you negative x, right? Now distribute the b. Plus bx squared minus bx minus 2b plus cx plus c. Now write the right side in descending order. Then 3x plus 16 equals ax squared. Do I have a square more? Yes. Plus bx squared. After x squared, I should put x's, right? Minus 4ax minus bx plus cx, and after that constants, plus 4a minus 2b plus c. Three x plus 16 equals, here factor x squared. You can write a plus b, then x squared. Here factor out x minus 4a minus b plus c and x. And keep the constants, 4a minus 2b plus c. You need x squared on the left side. Add here 0x squared. Correct? Now write your equations. A plus b equals to what? To 0. Negative 4a minus b plus c equals 3. Because you have x here, you have x here, the coefficient of x is 3. And 4a minus 2b plus c equals 16. 3 equations, correct? Now you have to solve the system of linear equation in 3 variables. Unfortunately, this one is not that quick. You have to deal with this, but you have a missing variable. Equation number 1 is ready for you. A plus b equals 0. You need to pair number 2 and number 3 and eliminate c. Then you can pair the new equation with number 1, right? This is what we learned when you are dealing with system of linear equations and 3 variables. To eliminate c between 2 and 3, you can multiply equation number 1 by -1, which gives you 4a plus b minus c equals -3. Copy equation number 3 under that. 4a minus 2b plus c equals 16, and add vertically, right? 4a gives you 8a. b minus 2b gives you -b. Positive c, negative c cancels out, equals -3, and 16 gives you 13. If you name this one equation number 4, now pair number 1 and number 4. I'll just do this. I'll copy it here. 8a minus b equal 13. Equation number 4. You see, now it's easy. You can cancel out the b's. A plus 8a gives you 9a equals what? 13. Why I end up with a fraction? From here, a equals 13 over 9. Let me double check. In my calculation, I shouldn't get a fraction. -4a minus b plus c. Let me distribute correct. Minus 4x plus 4, and here when you distribute x squared minus 2x plus x minus 2. Everything looks great. (4ax plus 4a plus bx squared minus b minus bx minus 2b. Everything correct. Ax squared bx squared minus 4ax minus bx plus cx, 4a minus 2b, 4a minus 2b plus c. Everything looks correct. We shouldn't end up with fraction, but it's okay. Minus b plus c times x. Yeah, everything is correct. I just double check why. Usually you don't end up with a fraction, but in this problem I end up with a fraction. Which is okay. Okay, now I have the value of A. Is it easy to find the value of B? Definitely yes, because look at equation number 1. A plus B equals 0. It means 13 over 9 plus B equals 0. It means B equals -13 over what? 9. Now you have these two. Is it easy to find the value of C? Yes. If you plug in equation number 3, which is 4a minus 2b plus c equals 16. If you plug in the value of a and b here, it will be 4 times 13 over 9 minus 2 times -13 over 9 plus c equal 16. I think I copied this problem from your book. They shouldn't give you at this level fractions. Let me double check if I copied the problem, maybe wrong. I'm sorry, but I have to check because I don't want to give you a lot of problems. It's okay to write those fractions that way, but for you, it's much better to have good numbers, right? 3x plus 16 over x plus 1 x minus 2 square. Everything is correct. Five point three. I'm sorry that this video takes a little bit long because I have to check the answer. Make sure that I don't give you the problem is correct because in your book they just ask you to set up the partial fractions, but I solved it. This is correct. Okay, here multiply. Unfortunately, you end up with fractions. Doesn't matter. 4 times 13 gives you 52 over 9. Negative times negative gives you positive. 2 times 13 gives you 26 over what? 9. Plus C equals 16. Now add these two, which gives you 78 over 9 plus C equals 16. Subtract 78 over 9 from both sides, then C equals 16 minus 78 over 9. You need a common denominator of 9. Wow, these numbers are growing really big. Here times 9 times 9, then C equals denominator 9. 9 times 16, 154 minus 78, which C equals 14 minus 8 gives you 6, and 14 minus 7 gives you 7. 76 over 9. Now you have the values of ABC. Plug in the value of ABC in the equation in step 1 and you're done. Why you end up with fraction in this problem? Because this problem was not calculated well in your book. They just ask you, actually they just ask to do a step 1 in this problem, but of course I continued to show you the solution, how to solve. That's why you end up with numbers with fractions, correct? This was actually all about part 2 of the lecture, when your denominator q of x has a repeated linear factor. I'll stop the lecture here and see you all in part 3 of this lecture, which we will discuss the fractions that the denominator has a quadratic factor, correct? We will talk about those.